Hey gang, this is just going to be a relatively quick video going through this sample test. It's not going to be explaining every problem step by step from scratch. More or less just kind of like going through the answer key. Maybe a few points of emphasis that would cross my mind. Yeah, just again, there's a relatively quick video just to kind of get the job done as we try to be ready for Monday's test. So, number one, find the general solution to the differential equation, or the diff-EQ. So we have to integrate, right? And in this case, it was U substitution. And so be ready for, when what you're doing is integrating, I guess you got to be ready for anything. There's not that much that you got to be ready for. The reference sheet you're able to have during the test. I don't know how much. I don't know if you're going to need it or not. But here it was U substitution, and I'll say this right now before moving on. If I am going to go too quick, obviously this is a video, you can pause as needed. Number two, this didn't need U substitution, but this right here ended up being, so this right here didn't integrate yet, just kind of rewrote this as being x to the negative 2 power, and this as being x to the negative 1 power. Now we integrate, and this is what I got, and that ends up being the final answer, because again, when you're just finding the general solution, you don't need to solve. They don't give you an initial value so that you could actually figure out what the C value would be. So this is a very general plus whatever plus C answer. Okay, so this is more like almost term by term integration. This one, so then they up the ante a little bit, or I do. I up the ante a little bit. And now it's about finding a particular solution, because we're giving you an initial value. So once you have the plus C solution, you can plug that in and get C. So how do we integrate this? Well, that, again, long story short, this is just kind of going through the key, more or less. This was another U substitution problem. So just be on your toes for things like U substitution. So this is how this one played out, which leads to all of this. And once you, and again, pause as needed, and once you have this, you can plug in the x and y value to figure out that C here for this equals 1, and so there's your final answer. Number 4, just one more with this particular solution stuff. Just term by term. So we're just integrating term by term. Easy peasy. And then we can get our C value, and this is the final answer that you should have got. Then we get into some slope fields. Just remember dy dx is basically saying slope. Slope equals whatever your x coordinate is at that point minus 2 times whatever the y coordinate was. So you just take each point's x and y coordinate and run this quick math. And you don't need to label. I'm assuming even with some like rough sketches, you can kind of be pretty close to what a -5, and that's pretty steep, but what a -5 slope would be, or a -4, or a +1 is maybe the easiest one next to a slope of 0. Maybe that's the easiest. But you don't need to label with these numbers. I just, for the sake of showing you this key and and checking your work, your answers. Boom, bam. All right, again, pause as needed. Number 6, little bit simpler. Very deliberate. At least making one of these as simple as just, okay, it's just all you need is the x coordinate for this one because you're just doing 2 times whatever the x coordinate is. So obviously, like for this column, it's always x equals -1. So when you throw it into here, it ends up being -2, and same over here, but +2. But again, hopefully not too crazy. Euler's method. So you got to run through the first 3 rows manually, and then you can go ahead into your calculator. Okay, just I will emphasize a couple things on top of just showing you the answers. Let's see, so we start with x equals 0, y equals 1, so that's how we begin. Just remember that to do the change of y, it's dy dx times delta x. It's like a formula for it. So whatever this gets you for your current x and y, so dy dx, whatever that is, times always positive 0.1. And again, well, maybe I'll also say this as a reminder. This is the change of y. It's not your new y. It's your change of y. So y goes from being this. With that change, it ends up being 0.8. And then you just rinse and repeat a couple more times. Right? So now dy dx, this x minus 2y, you use these numbers. But again, it's times the 0.1. And so you get this, which again, that's the change of y. So boom, bam, and one more time. But this, we don't actually do anything with that because you're stopping after the 3rd row. And now you go to your calculator program. The big thing I'll remind you of with that is make sure you first, before you execute the program, you first go into your y equals and you have to type in that differential equation into your y equals, like the specifically the y1 spot. So, yep, remember your program, what's the word, refers to or accesses, I can't think of the best word right now, but your program, you know, utilizes the y equals thing. It kind of accesses it. I don't know. So that would be the final answer that your calculator would tell you from your program that we did. So Number 8. Same thing, just remember that here we have a change of x of negative. So yeah, I mean, make sure you make it a negative. Yeah, so here really quickly is just the final answers for those first 3 rows, which then you would go to your calculator for the final answer, skipping all the other rows that would be there. But yeah. Solve these initial value problems. So this is where, we got 2x over y. So we're going to need a little bit of what? Separation of variables. Geez, that's the second time. You don't see this off the screen, but as my mouse goes up to here on my screen right now as I make this video, I could like X out this key, this active inspire. This is the second time I almost clicked on like Xing out this whole thing. Anyway, so you separate the variables, you integrate, you get c equals 1 with the initial value, and then what I want to emphasize here is like we get this, and you know what? On this test, I'll if it helps you, or if you think of it during the test when you're taking it, like I'm not going to get too meticulous, or I'm not gonna make a big deal out of how your final answer looks, right? Like solving for y, and all that jazz, you know. So like once, like in this situation, for example, once you get C and you plug it in, I'm not going to get too stressed about, you know, how your final answer looks, you know, again, solving for Y and all that stuff. But so any one of these, I'd be fine with. It's not the biggest point of emphasis. Like right, it's just, you know, separating the variables. But so there's that. And for number 9, number 10. Oop, this is a kind of almost like a special situation where how do you separate these variables? Well, first you have to do that little piece of algebra, and then yada yada yada, and then once again I think this is going to be another one where it's like, what's the final answer supposed to look like? But first, what you have to find C, and so you get to here eventually, which again I'm not going to get too hung up on how your final answer looks. So that'd be fine. You know, this might be a little better as we start to, you know, get that negative out of there, and as we start to, like, you know, try to solve for Y. But again, don't get too overly stressed. It's not what's the word? It's not the hill I'm ready to die on, or it's not our top priority. Pick my battles. But yeah, anyway. All right, then we get into this stuff. So once again, I'm just going to be like showing the key quickly, relatively quickly. But let's see here. There are a couple things I want to maybe mention. We'll see. Does it actually say the charcoal from a tree killed? All right, so this, okay, here we go. This doesn't literally mention that the exponential decay is, here we go, proportional to the amount present. When you see those words, you know to use like this formula when they say proportional to the amount present is the rate of growth or decay. But so what I'm saying is this: on the test, this is going to be one of those few situations where if it's like carbon dating or some kind of half-life situation, you're just going to have to know that this is the right formula for that situation. Okay? There might be one other moment like that, maybe with like Newton's law of cooling or something, but normally you're going to literally see words like proportional to this, or both to this or that, and that. But number 12. So see here, look, case in point. Literally it says proportional both to the number of students who have already heard the rumor. So when you see that word both, proportional both, you know that it's going to be this formula because of your formula sheet, especially. So maybe I'll also mention that. Like, I think on your formula sheet, it'll include, along with the formulas, the whole, what it applies to as far as what it's proportional to. So there we go. And remember, with these especially, you have to start off with, you know, a t equals 0. So you're kind of picking carefully, I guess. You know, you're you know, I wouldn't say like, I wouldn't go as far to say like you have your choice of what you can refer to as the t equals 0 moment. I'm sure pretty much everyone is going to pick the 4 days ago. So 4 days ago, we're calling, or I'm calling here, and you probably will too, I'm calling that moment t equals 0, and then yada yada yada. This is like the final answer. Again, pause as necessary. Oh, this says, if you can't tell, over 3,000. Oh, man. Over, if that got cut off a little bit, but that's over 3,000. Number 13, look, proportional to the quantity present, so you know to use that formula. And again, just mostly trying to just go through the answers and show you the key. So pause the video as needed. That's the answer you should have got. And then part B, yeah, just no extra comments here. Again, pause the video as needed. Okay, see, oh, here's the other moment. So like I said a couple minutes ago, carbon dating, half-life stuff, like that's going to be the just normal exponential growth decay formula. This is clearly Newton's law of cooling. That might be the other situation where you just have to know which kind of growth that is. Essentially what formula you use. So with Newton's law of cooling, it's this formula. Yeah. And once again, you have to pick your t equals 0 moment. I'm sure everyone's going to pick, the original, 96-degree moment. The egg starts off at 96 degrees. So that's what we're calling t equals 0, and yada, yada, yada. There's the rest of it, with the final answer of 14.473-ish. And then part B, the answer you should get is that for the 3-minute mark. That's it. Well, okay. So I guess that's it. I'm top of my head, other things as we look forward to taking the test. Nothing off the top of my head. I'll email you if I think of anything, but happy studying.